Hello guys, welcome to Information Theory. At the first, I'm gonna to explain you some important notice that is entropy. Before going to entropy, you must know how many type of source we have. At the first, the discrete source. What's the meaning of that? When your cardinality or alphabet is less than infinite, but the continuous source when your alphabet or your source cardinality is exactly infinite. But although we know we have a two source, but the element of the source, maybe they have a correlation together or not. If they have a correlation together, this type of source is with memory. If you're going to write the mathematically, pxn with condition x1, x2 until xn minus 1 is not exactly pxn. What's the meaning of that in concept? Your member, for example, you are in x10. It's not related to x1, x2, x3, x4 until x9. But when your memory is memory source, exactly pxn with condition x1, x2 until x minus 1 is exactly pxn. If you're going to write mathematically, it's something like this. Okay, guys. Right now at the first, I'm gonna to take a formula for discrete memoryless source. By abbreviation, we write DMS. Okay, what is the memory? I told you, it depends on the previous. Discrete. The alphabet is not infinity. Okay, if we have a discrete memoryless source, something like this, x1, x2, x3 until xn, if we're gonna to calculate entropy, at the first I calculate log of pxn, log of px2 until log of pxn. But if you see in this formula, the hx or entropy of x is px1 times log of px1 in the base 2. Why in the base 2? Because we work in computer until we can have another base. But we comfortable in computer by this. Also for x2 is this px2 times log px2 in the base 2, and until for xn, the formula is the same, pxn times log pxn in the base 2. After that, we must add or take an average for all of them, but in the last with a minus, guys. Therefore, our formula, if we're gonna to abbreviation and compact this formula, it's something like this. pxi times log pxi in the base 2. If we have, for example, x1, x2 until xn, summation of I from 1 to n. This is formula of entropy for discrete memoryless entropy. If we have a continuous, we must calculate with integration, and totally our calculation is so totally different. For example, you consider we have a source with two elements, x1 and x2. If they are binary, for example, x1 is p, x2 something like q, 1 minus p. If x1 is 1 over 2, also px2 is 1 over 2, guys, yes? Because 1 minus 2 is 1 over 2. But what's happened for hx? Hx is integration I from 1 to pxi log pxi in the base 2, by the way, is 1 over 2 log, in the, of course in the out is a minus log 1 over 2 in the base 2 plus also 1 over 2 log 1 over 2 in the base 2. We know by the logarithm that is minus 1. If you don't know any information about logarithm, please come back to my logarithm properties and teaching. I explain all of these things with detail. And also this part is minus 1. And therefore is minus 1 over 2. And also this part 1 minus 1 over 2. Our calculation is something this. Minus 1. Therefore our total answer is 1. Okay. Let's go to another important notice, guys. In binary discrete memoryless source, if we have a p equal to 1, therefore q is 0, yes? What's happened for logarithm? Because our formula for binary is something like this, p 0 log p0 in the base 2 plus p1 log p1 in the base 2. Guys, one of them is 0. Therefore, if this is 1, p of 1, also this part cancelled. And also p1. And therefore, if p is 1, if also in the first part I have a mistake, yes? Yeah, because that is p1, yes, times log p1 the base 2. But my meaning in the p1 is the q exactly. If I'm gonna to write the better, maybe is p times log p plus q log q in the base 2. If that is 1, this part cancel, yes, because log of p is 0, therefore this part cancel. And if q is 0, this part cancel, therefore answer is 0. And it has symmetric. Also, in binary discrete memory source, when your p is 0, it change. Exactly, that is p times log p plus q log q in the base 2. Therefore, by this part is cancelled, and also log of 1 in any base, you know that is 0. Therefore, this part is 0. If I'm gonna to show in the graph, it's something like this, guys. When our p and hx, when our p is 0, answer is 0. When is 1, answer is 0. In 1 over 2, we calculate also that is 1. Therefore, is something like this. That is our graph for entropy of p and q when they are binary. Okay, guys, let's go to another example. Excuse me. In here, our source is something like this. We have a 4 element every element PA is 1 over 2, PB is 1 over 4, and PC and D is 1 over 8. If we're gonna to calculate entropy, because they are discrete and memoryless, is something like this: Pxi log Pxi in the base 2. The calculation drive me to something like this: 1 over 2 log 1 over 2 in the base 2 plus 1 over 4 log 1 over 4 in the base 2. And also, because they are two types, all right, 2 times 1 over 8 times log 1 over 8 in the base 2. Therefore, if we're gonna to calculate this, is 1 over 4 with a minus, yes, 2. This is minus, and also 1 over 2 in the base 2, you know that is minus 2. Minus 2 times 1 over 4, also minus 1 over 2, and also 1 over 8 in the base 2 is minus 3, therefore is minus 3 in the base, in the denominator 4. Therefore, if we're gonna to take the same denominator, minus and minus, I put the positive, by 4 is 2, this part, and also 2, this part is 3. Total answer 7 over 4, guys. But the properties, guys, for entropy. At the first, if your memory is discrete and if your source is discrete, always entropy, guys, is positive. What is continuous? Maybe it can be negative, because when that is continuous, you shouldn't can calculate by sigma. You must calculate it by integration because it's continuous. Maybe we see in the previous lessons. Therefore, if your memory is discrete, always your entropy is positive. And another things, the entropy is continuous. What's the meaning of this? You know, if you change P, for example, a little, also your entropy increase a little. What is my continuity? My meaning of continuity is this: if you change a little P and therefore reduce a little Q, your entropy hasn't a dramatic change. Can you understand it? It's continuous. It's not by little change it goes to infinity. It's something like this. Therefore, that is continuous. But another thing is symmetric. Okay, you know, when you change the order of this part, it doesn't any change. Not just for binary, for all of them. You consider you have n element in your source. If you're gonna to change the order, it doesn't change the entropy. Why? Because it's summation Pxi log Pxi and something like this. Therefore, the order just that is between summation, it doesn't any change. But another things, guys, is so important. If your source is equiprobability, what's the meaning of that? I told you in here, x1, x2, xn. You consider you have a source x something like this, and how many members in here? 1, 2, 3 until n, and they are equiprobability. All of the probability of x1, x2, xn is the same, and is 1 over n. Therefore, entropy, we're gonna to see what's happened. Let's prove it, guys. In here, the entropy with respect to others, pxn, pxi, log pxi in the base 2, if I substitute by this element is in 1 over n log 1 over n in the base 2. But if you see all of this member from I to n is the same, therefore in a state of this summation I can write n times 1 over n times log 1 over n in the base 2, but in the entropy we have a minus, guys. Therefore I can cancel this and this, and total answer is minus log 1 over n in the base 2, and we know minus log in the base 2, we can write something like this, minus log a in the power 2. Instead of this we can put in the power, and that is log n in the base 2, because 1 over n, that is n minus 1, and minus is a positive. For example, if you consider something like this, guys, let me zoom out. Okay, something like this. We have a 8 alphabet in our source, and they are equiprobability. That means xi, the member, 1 over 8. Every member probability is 1 over 8. If we're gonna to calculate hx or entropy, it doesn't need we write the formula because they are probability. Therefore, answer is log of the cardinality in the base 2 and log of 8 in the base 2, or 3. But another things, guys, is so important. In here I have a theory, and that say if you're gonna to calculate the maximum entropy, your maximum entropy is something like this, log of cardinality of member in the base 2. And we know in the previous, when your probability is probability, yes, 1 over cardinality of x. And also that is inversible, guys. When that is happen, we know by the previous, we know this happened. And also if your entropy is something like this, you must sure your member probability is exactly 1 over cardinality of your source. Thank you for attention. Take care. I see you in the next video.